Is this working? Yeah, okay, I think it's working. So let's recap here what was going on when we left off. I maybe fixed Cirrus. Yeah, it's like, well, I think it still needs work, but that's not what I'm doing today. So let me take a look at my notes here. So fix me. I did fix this, right? Didn't I? I think this is fixed. Go in here. No post conditions. You can erase stuff. No post conditions. I think we fixed it. I mean, don't ask me how. I'd forget how. What's going on here on the git status? Yeah, that's right. I fixed one problem by making DFS do the right thing. I don't know if you can hear those sirens. And then, so I did that. What else? I just have a bunch of new log messages. Can't read this. I added some new log messages. I think the only thing here is, so we have some new log messages and, well, let me put it, the most important thing first there. What do they call that? Reverse pyramid order? Or it's a journalism term. It's like, I forget. I think it is called upside down pyramid or reverse pyramid. Anyway, so let's commit this as teach DFS how to follow junctions and add some logging stuff. Okay, whatever. Gut punch. All right, now, so I think I fixed that, which means we can get rid of this fix me. And I think I did fix this corner case. Maybe. Let's see, let's try something. So I think I remember, I'm trying to remember now. I think if I do something like this, and if I connect it to itself like this, everything's fine. But if I erase this, no bad post conditions. Oh, because the junction is actually still connected to itself. Right. What if we do something like this? And I go in here and I erase. So if I erase this, it'll DFS all the way around. It'll just make one net, right? So I do that. Now if I do this, if I erase here, it'll go around and make all of this one net. Oh, but then it'll follow the other neighbor here and go through the junction to make another net, right? Now what if I erase it here? There'll only be one net left. What if I erase it here? I think all this would just work. Let's try it. What about here? Yeah? What about here? That should work too. Let's try this. Yeah, I think it's fixed. I think if there's any bugs left now, they're things that I'm just going to have to run into at some point. One thing I want to do is, if there is a bad post condition, I want to know it. I want to know about it. So over here where we do CLS, what I want to do here is post, I'll just call it PC status equals false, goes true if an error is found in post conditions. This is going to be a pain in the butt here, but we're just going to have to add it into all the different places in post conditions. Then PC status equals true. I want to know about it, but I don't want to like kill everything in a big assertion failure. So my strategy here is I'll just change the background color if we hit a post condition. And then that way we'll notice things when they happen. Okay, so let's go in here. Now there should be a call to CLS. Okay, so we will do PC status. What would be a good error color? If I make it red, we won't be able to see it. If I make it pink, that actually I think would be fine. Fine, let's just make it pink. And 14 or 15. And just to see what that even looks like, let's just set it to true here for a second. I mean, you can still see what's going on. You can still play with it. It's just a really garish shade of pink. Okay, good. Put that to false. Now, I actually want to create a post condition. But I guess I don't. Okay, anyway, this is fine. So now if we ever hit a bad condition, we'll know it right away, which is what I want. Okay, now I'm just going to go ahead and say this is finished. The next thing to work on is register elements. So register elements should work very, very, very similar. Oh, actually, there is one thing I want to go through here. I was thinking about this. Let me draw that SR latch from the other day. So I'll put it here. I was thinking about it. If you wire a 1 up here, on the next frame, this gate will go to 0, and this output will go to 1. But it takes another frame for this gate to go to 1 and its output to go to 0. In other words, I mean, it's not by accident, but I basically created a situation where you have setup and hold time constraints. Now, on the off chance that A, someone is listening to this, and B, doesn't know what setup and hold time is, okay, what am I assuming of the people who are watching this stream? I assume that if you are watching, what part are we on? I assume that if you're watching part 14 of a very long and unedited sequence of videos about programming a logic circuits game, that you at least know what logic gates are, and that you at least know what a flip-flop is. You may have never run into setup and hold time before, so I'll explain it like this. Although an ideal flip-flop latches the value that you give to it when the clock hits a rising edge, any real flip-flop like made out of transistors or real circuits, actually has two constraints called the setup time and the hold time. And there's a bunch more constraints, but the setup time and the hold time are the most important. The setup time is how many cycles before the clock edge must your input be valid and stable. I said how many cycles. Let me repeat that sentence correctly. I said cycles because I'm thinking of my simulator here, where I think of every frame as a cycle. In the real world, there is some minimum number of like picoseconds where the input to your flip-flop has to be held at your target value and has to be stable. Like if you're wiring, if you know that on the next rising edge of the clock, you are going to put a 0, say, into your flip-flop, then your D input to the flip-flop must have been 0 for at least X nanoseconds before the clock's rising edge. And hold time means how long you need to hold that value after the rising edge. And this is all because, like, in the real world, gates are made out of transistors that have a non-zero time to change states and change conductivity and all that stuff. I mean, the times are ridiculously small, but they are non-zero. In this simulator, I have essentially done exactly that. It takes a cycle for values to propagate through a gate, which means that this RS latch takes 2 in-game frames to settle. So that means that, you know, in the world of this simulator, if I build this circuit and sell it to a customer, I would have to tell them what the setup and hold time constraints are. Well, okay, setup and hold time constraints are always like relative to a clock. So let's put in a clock. So over here is the clock input, and whoops. Oh, we hit a post condition. Gate 4, whatever that is, .3, unlisted net. I believe so. Port 3 is the one that points to the left. Now, why did that happen? Let's try and read the log, although I don't have high hopes for this. Let's check the most recent call to DFS. So we started at 2.5. Neighbor 2, which is to the left, was a net. So then we added Well, let's try and reduce this test case here. So let's say I have a gate. I guess it doesn't matter which. Whoa. Whoa. Man, I think we broke something that was working with all this stuff with the junctions. Whoa. All right. Let's put this in single click mode because otherwise it'll put a bunch of stuff in the log and we will deal with this. Okay, and let's also put some separators in the log. Okay, and erase that. No log messages. We didn't even call DFS? This should be a local. So it's not a gate, it's not a junction. How come we didn't get this log? Because we actually did delete the last coordinate of the net. Let's just do this here for a second. Put in our separators. Okay, let's take a look at what's going on with the coordinates. Net 1 has a single coordinate, which is 2, 1. 0, 1. What? Did I put this yx? That's the dump nets function, I think. Oh, I did put this yx. Actually, I feel like I've been doing that everywhere else and I just forgot. Nope, this is xy. So yeah, let's make this xy because that's what I would have expected it to be. Okay. So the net only has one coordinate in its list. Put in our separators. Erase that. How could we have not deleted the last coordinate of the net? I mean, don't get me wrong, that is the right thing. That should be happening. Okay, let's just do a test. Y equals 6. We will delete okay. So that says true. Does del return anything? Del returns the deleted item. Deleted nil. Didn't delete anything? I'm confused. Hold on, I'm gonna pour myself some water. So why didn't it delete anything? I mean, now we're really just like... so we're already dumping c.c, so... try to delete... So we put in our gate, we connect it to a wire. We look in here. We have one net with a single coordinate, which is 130, coordinate 1, 1. That is correct. It also has one port as part of the net object. That is also correct. And if I erase this, and let me put in some separators. Okay. If I erase this, what happens? Try to delete 130. But it didn't delete anything? Oh, wait, hold on. I think do I have the arguments wrong for delete? Delete table val. What am I doing wrong? Do I have a different name? Is it not C? The coordinates in a net, it's a set. I don't think it's a list. Right? Oh boy. Yeah. If we do c dot c of L equals nil. Now, this is where we should incorrectly get this. We didn't fix the post condition, but now we at least know what's going on. Don't ask me how this was working before. Wait a sec. How was this working before? Because before, when I was erasing squares, I was doing delete thing from table. And everything was... No. This is ridiculous. I need to know. I need to understand what's going on here. If I just have ordinary, whoops, if I just put in some ordinary wires, so I have one net, a bunch of stuff in it. If I erase that, two nets, a bunch of stuff in them. Excuse me, what? Oh, I see. I see, because whenever I erase a part of a wire, I do a DFS. Huh. Okay, let's actually fix this now. So let's also put in an assertion. Assert c.c.l and c.c of L equals nil. Now, if not next c.c, it's the whole reason I used next instead of checking its length. Delete the last chord of net. Edit all connected gates. This is what's going to fix the post condition, and ports to point to, or ports and all connected ports to point to blank. For p blah in pairs c dot g, do p dot neighbor equals blank for j blah in pairs c dot j, do j dot net equals blank. Yes, it's hideous. I know it is hideous. All right, so let's put in a gate, let's put in a wire, let's put in a wire, let's erase it. Everything's fine, everybody's happy, good. Okay, now, where were we? We were I was in the middle of characterizing my, my killer product here, my SR latch, and writing the data sheet for it, right? So, let's put in this guy, and I think I need, is it this guy I need? Can't remember. Anyway, clock comes in here. Oh yeah, I need to draw the whole rest of it there. Oops. Oh my God. Okay, we have got more problems. Gate, a bunch of gates are pointing now to unlisted nets. Okay, one of them actually has 2 ports pointing to unlisted nets. Yeah, okay, it's probably this one. So we did this, we did that, we did that. Let's see if there's anything helpful in the log. I honestly kind of doubt it. The log has been less and less helpful as of late. Zero, 1, 2, 0, 1, 2, 3, 4, 5, 0, 1, 2, 3. Apparently this claims to have 2 gate neighbors. DFS at 5, 3. Neighbor 3 is gate, neighbor 4 is gate. Let's try and recreate this. You know, I don't normally do this. In fact, I don't think I ever do this post condition check thing at work because, I mean, it takes extra time to write it in and I'm doing other things, you know. But because this is just my project and I can do whatever, I just decided to put it in because I thought it would help. But it's actually been really helpful, and I'm starting to think I should try to do stuff like this more often. I mean, I guess I do put a lot of asserts in my code. That's something that I learned from a friend of mine. Him and I were writing some code for like a project that we were doing, and I noticed that like he puts asserts everywhere. And it never bothered me, I never said anything, but I noticed that it was actually very helpful for 2 reasons. Because one, it caught a lot of bugs before, like, it caught them early, and it was a lot easier to fix stuff and keep it smooth. But also, like, it was helpful to explain certain assumptions about the code if you were reading through it. And ever since then, I use asserts everywhere. So it's not the quite, you know, the same thing as the post condition. And I guess a post condition is like, in the kind of code I write at work, it's just like a big long monolith of logic that has to get from one end to the other. So a post condition isn't really a useful concept. Yes, I'm aware that I have actually used the term post condition incorrectly. Post condition is usually applied to loops and not to like frames of a video game. Anyway, enough of that blathering. Let's keep going. So see if I can recreate this. Oh, that was easy. Wait, what? Didn't I just fix that? Does it make a difference what port you connected to? Oh, wait. I think this is the case where you have more than... Ah, okay. When it's directly adjacent to... Oh. Wait a second. This stuff here? I think I just also need to do it over here. Make a new net from R and return gates junctions. I wasn't even thinking. All right, let's think. Um, so what was this here? So this was the case where if we vaporized the last coordinate of a net, we need to make sure to set all of the connected gates and junctions to point to blank. So I don't understand, because when we do the DFS, all right, hold on. Let's improve this a little bit. Oops. Now, also, let's put this back to button P, as much as I don't like it. And now, the test case is 2 of them. All right, let's also put a separator in the log and erase that. And everything goes bad. Did not delete last coordinate of net. We did find a neighbor. This is in the loop that checks the 4 adjacent tiles of the grid to see if we can build a net out of any of them. Oh. DFS returns 0 gates, huh? But we even have a message here that says neighbor X's gate. I think I'm just not adding it to the list or something. DFS. Neighbor blank is gate. Else if type gate. Don't mark new gate as seen because we could approach it from other directions. See if he goes no recursive call in this case. Yeah, I'm just not adding it to the list. Duh. Oh, wait a sec. Wait. How come I don't add to port list? Whoa. If port I think maybe the P num. Yeah. I get it. Pnum equals pnum what of D. So we are the neighbor of the gate. Fate of the gate. The neighbor of fate. Sounds like I don't know. I was about to say like an emo band or something, but it sounds more like a bad fanfic. Anyway, we are the neighbor of the gate. So look up pnumlet in opposite direction. I can't think of any nicer way to say this, so yeah. I think that'll fix that issue, because I'm almost certain we didn't have this issue before. Go in here. Oh my goodness. Violated post condition. Assert n dot g of p. What's n? N, this n. Assert n dot g. Oh wait, p. Wait a second. Port, not p. Okay, now we should be good. Hey! Okay, great. I mean, all we're doing is debugging, but I'm actually really, really pleased that we're fixing all these little bugs here, because the longer a bug stays in your code, the more tendrils it extends and becomes harder to find and harder to extricate. So yeah, I am glad we found it. Now, if I go in here, component, put in, so let's read. Can we finally finish? I mean, it was even just a joke. It's not necessary for the program, but I want to figure out the setup and hold time of my SR latch. So 1, 2, 3, 1. Too much to ask. That component. That. Oh no, not that. This. No. This. So that will be our clock. This is our data, and I need to wire this up. Oops. Man, the longer it goes without turning pink, the more like scared I get. Okay, now. I guess let's make ourselves a clock. No. This is our clock. Now, just for grins and giggles, you got that, right? So let's do flashing lights warning, by the way. I mean, I say that, but like, I'm looking at the YouTube streaming page there. Concurrent viewers, 0. So who am I even saying it to? But anyway, flashing lights warning. Is this even working? I think I need to put one more delay in here. There we go. Okay, 1 second. So this is an active low clock. Let me just wire this with a constant 1. I know this is getting messy here. Okay, stop. Now, what's going on here? I think I'm not supposed to have a negator on the clock input. I think that's what's going on here. To get us through the gate run. Yeah, okay. Then I really need an input. It's so annoying to not have it. So now if I do this, yeah, okay, now let's, I mean, all in due course, right? Now last time I was able to get this to go crazy. I think these two clocks must have some relationship there, because this always ends up 1. I think I need. Let's try putting. So how many? I don't know, man. I don't really feel like counting it. Let me just try Oh no! What happened? Gate 16. I don't know what gate 16 is. What a mess. DFS returned 2 junctions. I don't think that's right. There's only 1 junction. And 3 gates. Now the 3 gates is correct. Where's the start of this DFS? Found neighbor. DFS at 2. Neighbor 2 is a net. Add. I think my debug neighbor numbers are not right. Anywho, add blah to coord list. DFS the next one. We found a net. Add blah to coord list. Add to port list. Junction connected. Keep DFSing. So far, I mean, I'm not following it like super closely, but found another net. Add to coord list. Found another net. Add to coord list. Found another net. Neighbor 4 is junction. Neighbor 4 is junction. Oh, I see. Okay. Luckily, I am printing the coordinates. So it's coordinate 2, 6, 0, 1, 2, 0, 1, 2, 3, 4, 5, 6. What? In what universe is neighbor 4 a junction? So, what happens if I just randomly erase some of the squares around here? Nah, of course that doesn't help. Even if I erase everything, it wouldn't help. My goal has just become to figure out the setup and hold time for that latch. And then subsequently the flip-flop that I would make with the second latch. Excuse me. But now it's just become a debug session. I mean, oh man. Okay, we got it to happen. Can we do it in a simpler way? What if we just do it with the gate? Okay, great. Okay, we found a simpler test case, which is nice. Let's just go in the log here. Okay, one thing I really need, which I should have done ages ago, is at the top of array square, I should really just do log erase square. Actually, I can do even better. If not t, then log erase square. Actually, I need to do it like this. Well, I don't need to, but it'll let me fit it on one line. All right, now let's put in our gate. Now, can we do it even simpler? Let's say we do something like this and like that. Okay, everything's fine. Let's just erase because I don't want junk inside the log. Also, I need to put this back on button P, don't I? Go in here, component, put a gate, put a wire. Component, put a gate, put a wire. Now, if I just erase this, everything's fine. Put a wire, put a wire, put a wire. Now, there's two different things I could erase, this one or that one. First, let's just try this. This is actually fine, okay? So now we know for sure the issue is, or the minimum version of the issue is if I do this and then, okay, so let's put a separator. And I erase this. So gate 1, port 4. Oh, I see. We need to put that in the sand timer section. I get it. All the way up here in the sand timer. Else, if it's a junction, and just for consistency, let's put gates before junctions. So if grid of L dot type equals gate, then corner case. No, not a corner case in DFS. It's a corner case in the caller to DFS. So here we will do if. But I need the, shoot. I need the neighbor number. Damn. I need the neighbor number. Which means that when I call DFS, I need to give it the neighbor number. Okay, there's another way to do this. It is less general and, in my opinion, less elegant, but it's a lot easier. Is right here in found neighbor. Blah, 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 blah. If neighbor.type equals junction, then I don't know what the hell all this is. I guess this could be an else if, right? These are mutually exclusive, aren't they? What's C? Yeah, C is in that. So these are mutually exclusive. We can make this an else if. If neighbor dot type whoops equals gate. Oh, no. This was right. If neighbor is a gate, then this is a corner case to clear the connection on that gate port. If neighbor.type is equal to gate, then, and then this will be an else if. And run DFS. Yeah. So this is where I'm fixing the problem, and there's just so many corner cases. Like, is it even possible, okay, to write this code and not have all these extra corner cases? Like, what if I had chosen a different data structure or a different way of handling the information? Would I have been able to write code with fewer branches? Again, I mean, I don't really care about the performance of having extra branches. What I mean to say is, like, when you have a lot of these extra branches to check for these little subtle extra conditions, the code becomes this delicate interconnected web of, it's just this, I don't know, it just becomes like brittle is how I would say it. And it's just harder to work with, it's uglier. If anybody else wants to look at it and understand it, they'd be like, well, why is there like 100 of these special cases? Anyway, this penum, do I do the same thing down here? No, I don't. Whatever, I'll just do it like this. If blah, then blah. If neighbor.port penum.neighbor equals C, then neighbor.neighbor equals nil. So that should fix that, actually. Ugh, I got it on slow mode. What? It didn't fix it. Okay, hold on. I need to put a log statement in here. Log found gate neighbor found net neighbor found junction neighbor put in a separator and then erase that. Erase square. Did not delete the last chord of net. Found net neighbor. Run a DFS. Found gate neighbor. So it did find a gate neighbor. Local penum equals penum let d log. Well, this should be minus d, shouldn't it? Or should it? We want the port on the neighbor. How does penumlet work again? Man, what a mess. Given self minus neighbor, return what port number it is on self. Okay, so D is neighbor minus us. So neighbor minus us. Yeah, this should return the port num on the neighbor log. Port penum. Oh no. The penum on neighbor. Log clearing. So we go in here, we put in our thing, we do that, and that. We go in here and we get ready to erase. So let's put in a separator. We do that. We didn't fix it. I know that. All I did is I changed the logs. Found gate neighbor and then nothing else. So clearly I've done something wrong. Oh, okay. I may as well leave this decaying. So bam, and then bam. Let's put in our separator, erase, port 4 on neighbor, clearing. That's right, isn't it? Oh, I set it to nil, which actually yeah, blank is the sentinel. We don't use nils for that. That's right. Actually, this should fix it. This should fix it. What? What do you mean? I must have that. Clearing. So did I do the clearing wrong? Oh, neighbor.port penum. Whoops. Okay, now this should clear it. Whoops. All right, we're back. Can I finally finish my design? So once again, from the top, let's draw our now ubiquitous SR latch. And then, whoops. Man, every time I erase anything, I just like cringe a little. I'm like, oh, it's gonna break again. Do that, and that. And then, so this, I would like to get it from a really slow clock, which I will now draw. Copy and paste would be really nice right now, but I did not implement it yet, so yeah. I'll do one more row after this. I mean, This editor is like this logic design editor that I have made here. It's definitely better than what it used to be, but it's still like it's not winning any awards for ease of use. Oh yeah, I think this last one I needed it to be the inverter. We go all the way back and we wire it up. Okay, so now we've got a really slow clock. And now let's, you know what? Why not? Let's put in the second, oh yeah, I need to actually do that. Let's put in the second SR latch. And now the clock is negated. Okay, so it's kind of amazing to me how I have now come to just expect things to work. What do I mean? Like, if you go back to video number, I don't know, 10 or something, or maybe even earlier than that, 5, who knows? Like when it first started simulating, I was jumping for joy. You know, I was ecstatic. And now it's like, it simulates. Of course it simulates. Why wouldn't it simulate? And it's like, it's just become like something I take for granted now. Of course, it's like I say though, I'm still terrified of my pink screen. Oh. Oh no! Houston, we have a problem, and it's not being flagged as a post condition. Oh, no. This isn't a problem. It's just like a misleading visual feature. Okay, I got scared for a second there. So, what do I mean by a misleading visual feature? Well, the junctions don't automatically connect to nets. They do automatically connect to gates. Maybe, fine, I'll put it as a potential fix me. I've noticed it before and I just decided it wasn't a big deal, but the fact that I sat there going like something's wrong. Junctions should auto connect. Oh no. Okay, good. I don't have to reset it. Yeah. Yeah. I was listening to Kinoko Teikoku earlier today. It took me a second to remember the name. And now I've got one of those. Shoot, I had the erase tool on. It's annoying. It's okay though. Oh. No. Actually, that might have been correct anyway. No, it wasn't correct. It definitely wasn't correct. Okay, do that. Good. Okay, now I've got the clock on both of them. What's going on here? Did I do something wrong? I think, it's kind of strange. So this is what you might call a defective flip-flop. It doesn't work. All right, let's try just like, I'm not going to erase it, but let's just try to, in our minds, ignore this second. Actually, why don't I erase it? So the problem here is that this wire is going to 1. Do I have something wired up wrong? I think I need to go frame by frame. So one thing that shoot, the way I've done this makes it hard. One thing I kind of want to do is just get like a little like preview of the clock so that when I'm going frame by frame, I can get an idea of how much time is left before the clock ticks. So this should give me a 3, 2, 1. I'm not winning any awards for this. Actually, I think it'll be more intuitive if I pull it up like this. This is just a little sneak preview. Dude, the junctions were extremely difficult. Well, I shouldn't say extremely, but they were really difficult, like way harder than I thought. And but now that I have them, like, shoot, damn. Oh my goodness, we desperately need an undo stack. Desperately, desperately, desperately. Oh. Right. Okay, great. So we've got ba-da-da, ba-da-da. Okay, good. So let's go frame by frame and try and understand what's going on. Okay. Okay, good. Good thing I added those. Now, right now, the clock is 0. And I guess what this means is that first SR latch is actually sensitive to, it's like it's active low. Now, as soon as the clock goes high, which won't change the gates right away, so let's go one more frame. Clock goes high. Now what should happen? Well, that top left gate will go to 1, which will put its output to 0. And nothing should change, right? Nothing should change. And nothing changes. So for here, that bottom gate's output should stay high. The bottom gate's state should stay at 0, or the bottom right gate. I'm talking about like that first SR latch on the left. I'm ignoring the one on the right. So the bottom right gate should stay the same. The top right gate should also stay the same, unless this is a case where it looks like the wire is connected, but it really isn't, because that's a junction right under the gate. I'll bet you that's what's going on. Yeah, I think that fix me with a question mark is going to become a fix me with not a question mark. Yeah, okay, that's exactly what's happening. That is exactly what's happening. Yeah, that was it. That was it. Now the other thing is nothing. We fixed that first SR latch. Now let's wire up the second one. Yeah, I think we need to deal with that, which is not going to be easy. It's just, well, it's not that it's not going to be easy. I mean, it'll be super easy. What will be difficult is trying to do it in a way that keeps the code like clean and organized. I mean, I think I've kept the spaghettification factor at a moderate level. It's definitely not a low level, but it's at a moderate level. But the spaghetti factor is rising quickly every time I add a special case for yet another thing. So that's what's difficult, is avoiding the spaghetti. I mean, if I just wanted to add that special case, I would go into the place junction and add a bunch of, if logic to check for gates. And I would do the same thing in the place gate function to do if logic to check for junctions. And I can do that. Anywho, now the thing I care about is pop that guy in there, put that there, and again, flashing lights warning. See if we can. Let's try changing this period. Oh, okay, we got it to happen. So now here, this is not a bug, I don't think, in the simulation. I actually think this is... Hey, wait a second. Oh yeah, that first one's active low. Oh yeah, okay, hold on, let me... Okay, so at this point, it's active low. Yeah. Yeah, this has a hold time of 2, or 1. Wait. I'll call it a hold time of 1, because you need to hold the input steady for 1 more cycle after the clock changes. Because see what's happening here is that the clock on the left one is active, right? Because it's active low. And excuse me. That top right flop in the first latch, it actually should be 1. That bottom right flop, though, wait, maybe this is correct. No, it shouldn't be correct. Yeah, because here the clock is 0. Or not the clock, the data input is 0. The clock is also 0. Data input is 0, and right now everything looks fine. Wait a second. If the D input were to stay at 0, what would happen? Well, that bottom right gate will go high. Meaning its output would go low. Meaning the top right gate's state would go low and its output would go high. I think maybe I have the inverter at the wrong place for the D input. Let's just quickly try it out here. Rezoom. And just erase this. Oh, I get it. This is a case, yeah, I get it. I see the issue. Yeah, this is a case of when I was going frame by frame, I was forgetting the fact that all of my gates have a 1 cycle delay. Or to be precise, those two clock gator gates, the leftmost two gates in the SR latch, those ones had a gate delay and I was forgetting that. Yeah, so between the time that this input changes, okay, let's make it a little bit slower, just slightly slower. Actually, maybe even just 1 cycle. Well, let's make it 2 cycles, or 2 frames, or whatever you want to say. Just so that it's easier to see when we're single stepping. So right now the clock is disabled, so let's keep going. Okay. Now, the clock is enabled. Now, the output of the D input is 1, which means the top gate is going to go to 1. Why is the bottom gate going to... Oh, because I forgot about the inverter. The bottom gate goes to 1. The bottom right gate will now go to 0. Oh, but okay, hold on. Okay, so now it's 0. Now the latch should stay the same. Oh, no, it doesn't. Right, okay. Now the latch should stay the same. Right? Because on the next cycle, the output of my little test driver circuit there is still going to be 0. What? What's going on? Okay, I need to make this slower still. Oops. Resume. Nice Christmas colors though. Okay. Now we will go frame by frame. So what I'm going to do is I'm going to count how many ticks it takes between when... Okay, so 1 tick to propagate through the first gates, 2 ticks to propagate through the second gates, 3 ticks for the second gates to settle. Now everything should stay constant. So actually the hold time is... We'll either call it 3 ticks because it's 3 ticks in total, but usually hold time is like measured as time after the clock edge that things need to stay stable. And the clock edge is on the first frame, so it's like +2 frames of hold that we need, if that makes any sense. So now if I keep single stepping, takes 3, but now it's good. And then takes 3, now it's good. Takes 3, 2, 3, now it's good. And so on. Yeah, so this is not a bug in the simulation. It is a bug in my actual design. It's not really a bug in my design, it's just a property of the design. I mean, all of this would go away when I put in the register elements because you would never even bother to draw a flip-flop like this. You would just draw it with like delay elements. Clock ticks. Now, that first SR latch takes 1, 2, it's already stable, so the second SR latch is good to go. Yeah, so actually, if we resume this, do we ever run into a case? Oh, cool. Oh, never mind, not cool. Oh, of course, because it's hold time after the clock edge. Hold time after the clock edge. Yeah, so for better or for worse, anybody using the simulator, if they want to do stuff like this, they will just have to like basically do static timing analysis in their heads. That's kind of funny to me. Yeah. So at some point, it should happen at a multiple of 5 clock ticks. 2, 3, 4, and now on this one, it should flicker. Oh, wait, did I miscount? Maybe on this one it'll flicker? Okay. And then 1, 2, 3, 4, 5. Yeah, now it flickers. The reason is because wait. What's the reason? Because this has a period of whatever. It's like, I don't know. Maybe it's not 5, maybe, yeah, I'm not sure. But anyway, the point is, this is violating hold time. And setup doesn't really figure into the equation in what I'm doing right now because like, oh, fascinating. Wait a second. Maybe I do have setup problems because, yeah. You see how when this output, okay, not when it flickers, but you see when this output changes, it like is delayed a little bit. It's like, maybe on this one it'll happen. It'll be like, took a chunk. Yeah, you see that? That took a chunk. I think this is a setup time thing. I think the reason is because we need to delay the clock. I'm not sure by how much. Well, I'm not sure. But yeah, actually, so that's cool. It was totally unintended. I didn't really think it would be such an obvious and immediate problem in like the very first thing I decided to draw in the simulator. But to be honest, I'm kind of happy about it. Like, I want people playing this game. Well, it's not really a game right now, it's a sandbox right now, but one day it'll be a game. I want people playing the game to like use this to understand these subtler concepts of like timing when you're doing digital circuits. I mean, that's a win. I consider that a win. And you know, well, yeah, it's a win. Yeah, and if so one of the reasons why this is not ready to put into the hands of players quite yet. One of the reasons is because like there's no easy way to go frame by frame. I mean, like I can do it using the Pico 8's built-in frame by frame mode, but like there should be a built-in way in the game to do it, or to speed up or slow down simulation, and stuff like that. And Still need delay elements. We need nice input-output elements, so it'd be nice to just have some like buttons you could push, like in Logisim, but it would be a lot nicer if we actually made a game out of this where there's some objective. Well, yes and no. I heard, was it a podcast or an article? I can't remember. It's a long time ago, but it was involving the developers at Cly, the studio that made Don't Starve, among other things. They were talking about Don't Starve, or maybe it wasn't Cly. It was somebody talking about Don't Starve, and I think it was a dev though, because they were mentioning how in an early prototype of the game, they would like basically give a quest to the player to try and like, it was like the form of a tutorial, right? So once you played the tutorial, you would know how to play the game, and then you could do whatever. But so basically the tutorial was just like, do this, now do this, now do this, now do this, and the devs were saying like, well, what started happening was people would play the tutorial and then they would finish it and then they would play the main game and just have no idea what to do. They weren't in the mindset of creating their own game for themselves, creating their own objectives for themselves. So on the one hand, having objectives is the difference between a sandbox and a game. On the other hand, having objectives can kind of like pigeonhole the player into just getting bored of it and thinking they've essentially quote unquote finished it and moving on, and never really exploring what they're capable of doing. I mean, but let's not forget though. I mean, Don't Starve does have an objective. Like, let's not, the thing is that the objectives are just not that specific. The objective is just like continue to survive, and then, well, I don't want to spoil too much for people who haven't played it, but you discover things that create new objectives. Anyway, I don't want to say too much. Okay, so all that spiel out of the way. Yeah. I got nothing more to say. I think I'm done working on this for today. But this is good. We fixed a bunch of really subtle bugs. And I thought about setup in the whole time. And yeah, let's push it to GitLab. Ta-da. Okay. Fix some what should I call this? And commit messages can be hard to write sometimes. I don't know. Fix some dangling net pointer bugs. Make post condition violations more obvious, etc. Get that in there. Okay.